Today's lecture is on geometrical optics or ray optics. This is FFBMD YouTube channel, and I am going to talk about the geometrical optics and ray optics. In this chapter, light is considered to travel from one point to another along a straight line. This straight line path of light is called ray. The bundle of such ray constitute beam. Reflection. In this phenomenon, light returns to its own medium after striking the boundary plane separating two media. This is shown here. This is a boundary separating two medium. One medium is upward and above this boundary, and second medium is below this boundary. And light after striking it get back. Then the phenomenon will be called reflection. Now, law of reflection. Angle of incidence is equal to the angle of reflection. Second, the incident ray, reflected ray, and normal to the reflecting surface all lie in the same plane. These laws are followed by plane boundary surface as well as curved boundary surface at every point. Here the situation is shown. This is a plane surface boundary. This is a curved surface boundary. This is also a curved surface boundary. And this point is called point of incidence in this case. This is the point of incidence in this case. This is the point of incidence in this case. This is the angle of this is the incident ray, and this is the reflected ray. Here it is incident ray, and this is reflected ray. Incident ray and reflected ray. And this is the normal. If we draw a perpendicular at point of incidence, then that line will be called normal. This is normal, and this angle is called angle of incidence, and this angle is called angle of reflection. That is angle made by the incident ray. Angle made by the incident ray. That is the angle made by incident ray with the normal is called angle of incidence, and angle made by the reflected ray with the normal is called angle of refraction. So this is the angle of incidence, and this is the angle of reflection. It is represented by I, and angle of incidence is represented by, and angle of reflection is represented by R. And here we have talked all about this. And from the first law, angle of incidence will be equal to the angle of reflection, and from the second law, these all three line must be in the same plane. That is this line, angle of that is incident ray, reflected ray, and the normal must be in the same plane in all these cases. Now another point, when a beam of light is incident on the interface between two media, three situations can happen. These are: first, some part of incident light is sent back into the first medium, it is called reflection. Two, a part of light gets transmitted through the interface, that is, it is called refraction, and the rest part of the light gets absorbed by the medium, it is called absorption. Now we are going to discuss about the mirror. It is a most it is the most part of light. If the most part of light incident on the interface of two media is reflected, then the interface is called mirror. Generally, a smooth and polished surface is called mirror. It is of two types. Plane mirror, the reflecting surface is plane. Curved mirror, the reflecting surface is curved. Here you can see the symbol of a mirror. This represents a plane or a surface, and this side is reflecting side, that is light strikes this and get reflected, and this side will be polished, that is this side is called polished, represented by this line. Here in this case this side is reflecting and this side is polished, and this will be called convex mirror, and this will be called plane mirror. Same case here, this side is polished and this side is reflecting, so this is concave mirror. There may be different types of mirror. Here this is a spherical mirror, that is these are the part of a spherical mirror. This side is polished and this is reflecting surface. Here in this case this side is polished and this side is reflecting surface. Actually generally mirror is made by polishing a glass plate, side of glass plate with a chemical silver bromide, and another side remains unpolished, then the another side of that surface will behave like a mirror. Now a spherical mirror. It is a part of a sphere, a spherical reflecting surface. Next is concave mirror. It is a part of a hollow sphere having outer part that is bulging surface silvered and the inner part that is depressed surface as a reflecting surface. Then it will be called concave mirror. Here the situation is shown. The bulging part is this, and this is a plane and reflecting part, and the depressed part is this, and this is polished part. So this will be called convex mirror. Uh, and this is the situation for concave mirror. Here this is the bulging surface is silver, that is this part is bulging, so this is silver, and depressed part is uh, reflecting, so this will be called concave mirror. And in this case bulging part is reflecting and depressed part is silver, so this will be called convex mirror. In this case this is the reflecting surface and this is the silvered surface. In this case this is the reflecting surface and this is the silvered surface, that is no reflection take place from the side of silvered or polished surface. Convex mirror. It is a part of hollow sphere having inner part. It is a part of hollow sphere having inner part that is depressed surface silvered and the outer part that is bulging surface as a reflecting surface. Here this is shown, this is a hollow sphere and one part is cutted and polished like this. This part is polished and this part is reflecting, so bulging surface is reflecting in this case, so this will be called convex mirror. It is also, and in this because bulging part is silvered and depressed part is reflecting, so this will be called concave mirror. And the center of the sphere is called center, and the distance, the half distance between this point and C is called focus. Here this is focus, and the middle part of the reflecting surface is called pole. A line passes through the pole is called axis, and this is called center of curvature. This is focus. Here mm dash, that is mm dash or nn dash represent the aperture of mirror, that is effective diameter where reflection take place, and cp, that is this distance, This that is radius of a spherical part equals to r equals to radius of curvature. This is called radius of curvature. This distance or this distance will be called radius of curvature. And fp, that is this distance, f equals to focal length. Here this is a focal length. And aa dash, that is this line passing through the center of curvature, is principal axis of mirror. Now sign convention, Cartesian sign convention. First point, all distance is measured from the pole. Second point, the distance measured in the direction of incident light is positive and opposite to it is negative. Third, the distance measured above the principal axis is positive and below the axis is negative. In this case, let's see.